students, today we will discuss about the 8086 microprocessor programs. So today the concept of the program is sum of n numbers. In today program, I'll teach you very clearly with the explanation how it working step by step. Same you can follow for rest of the programs. So the address I'm taking, the starting address of the program is 1000. Okay, these are the mnemonics and these are the comment. Okay, the first instruction. So here you can see I have made a table. So every time after execution of every instruction, I can update this value so that you can understand the concept very clearly. Okay, so once after the first instruction execution, move si comma 0500h. It means it load the 0500h into the source index register. So here I made si, so it will be loaded with the value of 0500. Right, now I am taking then next instruction, move di comma 000h. So it is loaded, di is loaded with 0600. Okay, now I will take a set of values. Okay, so like a 0501, 0502, 0503, 0504. The corresponding data are, this one I will take it as a 4. Okay, now move ax comma 0000. So I am initializing ax as 00. So it is ax, right? So ax is 16-bit register, this is 8-bit, this is 8-bit. Okay, now see here the first address, that is a 0500, hold the content of 04. This I am giving for number of count. Okay, suppose see here it load the number, load the block size, the value of n. So here I am taking 4. Here I can use n number of values. Here I can make it as a 10, 11. Accordingly you can provide the input. Okay, here I am making it as a 4. So that means CL will be the content of, here what is the first I have loaded. So I have loaded only this one only now. Okay, so I was loading only 0500. Okay, in the second instruction 06 is loaded. Okay, in third instruction is initialized, and see the current SI content is 04, so that is going to CL, right? So that means 04. So that is a, okay, so this is a looping, so this number of looping it will check. Okay, so here I can load n number of values. Okay, here I just, for example, I took 4 values. Now increment si. So now current value is 0501 00. If it is incremented, it will go to 0501. Okay, now the content of si. What is the current address si? 0501. What is the holding data? 03. So that is going to AL. So that means AL equal to AL plus the content of si. Right. So now the AL is 00. When it add with 03, so it will be 03. Right. So now ADC AH00. So what is this instruction will do? AH equal to AH plus 00 plus the carry. Okay, this is the what the instruction will do. So add AH and 00H along with the carry. Okay, now so you don't have any carry, so you have only 00. Now increment si. Now what is the current value? 0501. So if it incremented 0502, that is the current value. Okay, now decrement CL. What is the CL value? CO04. Now it is decremented to 03. So now very important, see here, jump if it is non-zero. So back is a label. So while you writing a program in lab, we'll be using offset address to track this loop, right? But when you're writing a program, so what we need to do is we need to put some label, okay, instead of offset address. So back JNZ, that means if zero flag is not set, that means your CL is non-zero, right? So CL is now current value is 03. It is not equal to 0. That means condition is satisfied. That means zero flag is not set. Okay, so CL is non-zero means it will go to the loop back. So I am repeating again. If CL is not equal to 0, it will, while executing this instruction, it will check the current value of CL. The CL is now 03, so it is not equal to 0, so it will go to the loop back. Okay, so now what is the current value of SI? 0, address is 0502. What is the holding data? 02. So that will added with this. After execution of this instruction, it will be updated as 5. Why? Before it was 03. When it add with this 02, it will become 05. So that's what we are writing, right? Add AL comma content of SI. That means AL equal to AL plus content of SI. That gives 05. Now ADC AH00. So again, so there is no carry. So you will be having only 00. Now increment SI. Now current address of SI is 0503. Now decrement CL as 02 one time. Now again check jump non-zero. Now again the CL is become 02. Whether CL is 0? No, it is non-zero, right? So condition is satisfied. So 0 flag is not set, right? Again it go back to the label back and it will do the process. So add EL comma content of SI. What is the current SI? 01. So it will be on 06. Now load value of 00AH, add with the carry. So there is no carry, so you will be having only 00 only. Now increment SI. What is the current value of SI? 03. Now it is incremented to 04. So now decrement CL to 01. Okay, whether CL is 1, whether it is equal to 0? No. Okay, so 0 flag is not set. 0 flag again, now it is not set, right? So again it back to the loop back and it do the process again. So add AL comma the content of SI. So what happened? So this 06 will become 08, because 06 will be added with 02, it becomes 08. Now ADC AH comma 00. Now there is no carry again, so you will be having 00 only. Now increment the current SI. So if you increment the current SI, 0505. Okay, now decrement the current value of CL 00. Very important. Now current value of CL is 00. So that means 0 flag will set. 0 flag will set. So that means the condition failed, right? So the condition failed, so loop will not work. So it will break, it will go to the next instruction. What is the current value of AX? AX is, the current value of AX is 00008. So that is going to your DI address, right? And what is a D address? 0600. In that value will be loaded 00008. DI is a 16-bit register where we are storing your AX value. Now HLT, you stop the execution. So this is a way you want to understand the program. So similarly, you can make a table for the programs and you can understand how the program is executing.